Compare the intercepts of the functions y1, y2, and y3 by analyzing their graphs and tables. Okay, so let's first look at our y-intercepts, and in our table, then the y-intercepts when x equals 0, and so y1 will have a y-intercept at -4, y2, 3.1429, and y3, 4 and 78 10,000ths. So let's just go ahead and mark those in our graph as well. So we did see y1 is 0, -4, y2, 0, 3, and 1,429 10,000ths, and then 0, 4, and 78 10,000ths for y3. And then looking at our x-intercepts, then this should be when y is 0. And so looking at y1 in the table first, then we see y is 0 when x equals 4, and y is also 0 here when x equals 10. So there should be 2 there, and then at y2, looking for 0, we don't see one there, and then at y3, we don't see one there either. And so that doesn't mean they don't have a y-intercept, it just means that between, it's not one of these integers, -2 through 11. And so we'll look at the graphs and see what we get. So for y1, we do have an x-intercept at 4, 0 and 10, 0. And then at y2 and y3, we didn't have these in the graph, but notice that for y2, we do have an x-intercept here, but the x-intercept is not an integer, which is why it wasn't in our table. And so it'll be a little bit bigger than 7. And so we'll just say, 7 just for simplicity, but it's a little bit bigger than 7. And then 0. And then we see here that y3 doesn't appear to go down as far to even cross the x-axis. And so it doesn't look like we have one there for our y3. And so let's go ahead and summarize these findings. The y-intercepts of y1 are 4, 0, and 10, 0. The x-intercept of y2 is a little to the left of 7, 0. There doesn't appear to be an x-intercept for y3. The y-intercept of y1 is 0, -4. The y-intercept of y2 is a little above 0, 3. And the y-intercept of y3 is a little above 0, 4. According to the table, the y-intercept of y2 is 0, 3, and 1,429 10,000ths, and the y-intercept of y3 is 0, 4, and 78 10,000ths.